511. This is Dr. Keisler, and this week we're going to be discussing experimental research and experimental research design. So we spent some time in the beginning of the chapter talking about the uniqueness of experimental research. Experimental research is unique in that it's the only type of research that directly attempts to influence a particular variable, and it is the only type that, if it's used properly, can really test hypothesis about cause and effect relationships. So really it's the best type of research to use for testing hypotheses. Experimental research considers a few different things. First, experimental research looks at an independent variable, which is the treatment, and a dependent variable, which is the outcome. So this is how you can use experimental research to determine cause and effect relationships. So there are a few different characteristics of experimental research. One is that the researcher manipulates some type of independent variable, right? The researcher decides the nature and the extent of that particular treatment. And then after that treatment has been administered, the researchers observe or they measure the group receiving the treatment to see if they differ. Experimental research really enables researchers to go beyond just description and prediction, and it's an attempt to help determine what caused the effects. One of the keys to experimental research is this idea of randomization, right? If you think back to a couple of weeks ago when we had our discussion on sampling procedure, we talked about this idea of random selection, right, of our different sample populations. But random assignment is similar, but it's not quite identical to random selection. But random assignment is a really important ingredient in the best kinds of experimental research designs. And essentially what it means is that every individual who's participating in the experiment has an equal chance of being assigned to any of the experimental or control conditions that are being compared, right? So randomization refers to that process of assigning the groups, and in some of the best designs you want to make sure that those groups that the researcher is taking a look at have some type of equivalency. So if you think back to our discussion of threats to internal validity, we talked about this idea of extraneous variables. And essentially extraneous variables are those threats to internal validity. So in experimental design, the researcher has the ability to control many aspects of the experiment. It's actually the responsibility of the researcher to try to control for these, because you're trying to control for possible threats to internal validity. So one of the ways that this is done is by ensuring that all the subject characteristics that might have an effect on that study are controlled in some way. So you're looking to control those potential differences in subject characteristics. So there are a few different ways that you can go about trying to control those subject characteristics. And essentially, again, what you're trying to do is eliminate threats to the research, right, and to your outcomes. You're trying to control those extraneous variables. So some of the ways that you can do that is through randomization. So like we mentioned on the slide before, if the subjects in a study can be randomly assigned to either the experimental group or the control group in the experiment, then the researcher can assume that they have a greater likelihood of making those groups equivalent, right? So this is considered the best way to ensure that the effects of one or more of the extraneous variables have been controlled. Another way you can do this is by holding particular variables constant, right? So the idea is that you're trying to eliminate the effect of one of these extraneous variables by taking it out of the study, right? By removing it from the study. So um, let's say that there's a variable of gender, right? So if you were going to go ahead and you were going to do a study and you had some suspicion that gender could influence the outcome of that study, well, then you would want to make sure that you could um, control for it by making sure that your subjects were all of one particular gender, right? So you can try to hold one of those subject characteristics, in this case, gender, you want to try to hold it constant, right? So if you restricted your subjects to all one gender, then essentially what you're doing is you're holding that variable constant, right? Because you had a suspicion that gender might influence the outcome of your study. Um, on kind of the flip side, you can put that variable into the design, right? So if you thought, just like in the other instance, that gender might influence the outcome of the study, what you could do is um, make sure that your study has both males and females as different groups that you're going to look at in the study, but you can then um, do your treatment and you can look at the effects or the outcomes that um, your treatment had on both groups to see if there was indeed a difference. So you would have um, hold one group as all female and hold one group as all male, give them both the treatment, and then you can go ahead and you can look at those outcomes. So you build that variable or um, that potential threat into the design of your experiment itself. Another way to eliminate the threats is through, and you're going to see these as we go through all of the ways that you can design an experiment. You're going to see how these things are built into the different experimental designs that you can have. So matching is another way that you can potentially eliminate some of those threats. And with matching, really what you're doing is you're looking at the subjects and you're looking for particular variables that they may have in common that you feel could affect the outcome of the study. And then what you do is you consider those two subjects a pair, and you go ahead and you put kind of as randomly as possible, you put one member of that pair in one of the groups, and you put one member of the pair in the other group that you're going to compare, right? So one goes into the control group and one goes into the comparison group. But you would already determine that by some shared characteristic that those two subjects were a pair. So let's say you were looking at, age, or you wanted to look at race, and these are subject characteristics that you feel could potentially influence the outcome of your study. As you matched them, you would then want to make sure that, you had a teenager in the experimental group and then a teenager in your control group, because you would have decided that the two teenagers in your group were a match. So that's another way that you can try to control for those threats. You can also use the subjects themselves as their own controls, right? The subject's performance is, measured or assessed under all of the treatments in the study or in the absence of the treatment and then under the treatment. So instead of having a control group and experimental group, you have the subjects first do the performance or the assessments without the treatment, and you can look at that data, and then you go ahead and you have that group do the treatment and you look at that data. So they become both kind of the control group and the experimental group, but you're measuring the performance before and after the treatment so that you can see if any change actually did occur. And that last way that you can eliminate threats is to do what we call an analysis of covariance. So we haven't done these chapters yet, so we've kind of skipped ahead a little bit, and a deeper discussion of covariance happens in when we get to chapter 11 and we get into our discussion of inferential statistics. So you don't have to worry about it too much right now, but essentially you're using statistical methods to equate to compare the groups to one another on the basis of some kind of pretest or other variable that the researcher has already determined. So we'll talk about that when we get to the inferential statistics chapter more. So we've got a bunch of different experimental designs that were discussed, and some are considered weak experimental designs, and some were considered kind of good, strong examples or true experimental designs. So in a poor experimental design, which would be, and we'll talk about this one-shot case study, one group pretest post-test, static group comparison design, or the static group pretest post-test design. These are all considered poor experimental designs because they don't have any built-in controls for threats to internal validity. When you have that one-shot case study, which is shown to you up here, you take a single group and you expose it to a treatment or an event, and then you assess the effects. So in this case, you take your group, they eat pie, you test their blood sugar, right? In this one group pre-test, post-test design, what you're doing is you're taking that single group again, and you're measuring or observing what happens both before and after exposure to that treatment. So you go ahead and you measure their blood sugar, you let them eat the pie, and then you measure the blood sugar again. Can you see the bottom? Okay, we can see the bottom of this one, sorry. With the static group comparison, what you're doing is you have two groups, but they receive a different treatment. So you've got this experimental group, this control group. Here you let your experimental group eat the pie, and then, I lost my thing, sorry. Over here you test the blood sugar of both the experimental group and of the control group. So like I said, these are all considered weaker experimental designs. If you think about this one-shot case study, you have no control, right? So how do you know that the results are due to the treatment? And you don't know anything about what that group was like before the treatment because you didn't do anything. I'm sorry, I keep losing my cursor here. And it doesn't want to show on the screen. Okay. But you keep, you don't know what that group was like before. So you didn't do any pre-testing. So really all you know is what they were, what they were like after they ate that pie. So you can see in there, you have a lot of potential threats due to subject characteristics in that one-shot case study design. So with the pre-test, post-test design, you know if the changes occurred because you did, let's say, measure that blood sugar first, they ate the pie, and then you measure their blood sugar again, but you don't really know if it's because of the treatment since there were really no attempts in this design to control for any of the other threats to internal validity. So if you think back to our chapter in terms of, history, maturation, testing, instrument decay, all of those things, there's no attempt to control for any of that here because you only have the one group, right? You only have that one experimental group. In the static group comparison, it's still better, but it's still considered a weak design, mostly because you really know little about the different subject characteristics. So you've got, in this case, two groups, right here you've got your experimental group and you have a control group, but if you see here, you didn't go ahead and do any kind of pre-testing. So you know that there were differences perhaps between the group that ate the pie and the group that didn't eat the pie, but you don't know what those differences were before. So all of these are considered examples of weak experimental design. So what you're going for when you design a research study, when possible, is what we call true experimental designs. So true experimental designs, the essential ingredient of a true experiment is that random assignment, right? So this is one of your most powerful tools to control some of those threats to internal validity. We've got three different kinds of true experimental designs, and those are the randomized post-test only control group, the randomized pre-test post-test control group, and then the randomized Solomon four-square group design. So let's go ahead and we'll take a look at examples of each of these. So this would be an example of a randomized post-test only control group design. So you see here that you've got 100 teachers randomly selected. You put 50 teachers in each group randomly, right? So here they're randomly selected. Whoop, there we go. Here you're randomly selected. But then here is your randomization, right, which is a little bit different, your random assignment. So they're randomly then put into these two groups. And in this case, your group gets the sensitivity training. In this case, they don't get the sensitivity training. And then you go ahead and you do a post-test on both groups, right? So with these, you have two groups, but they're receiving different treatments, and then you're testing both of them at the end. So one of the things that is strong about this design is that it can control for certain subject characteristics. It can somewhat control for maturation threat and for regression, but it doesn't really control for subjects' attitudes, the threat of mortality, and potentially or maybe implementation or data collector issues or biases, location, or history. And so if you take a look at this, you probably see that you don't necessarily have a lot of information about the group in terms of pre-testing, right? So you didn't get any information on the subject characteristics, kind of what they were like before the treatment. You're just taking a look to see if there's a difference between two groups who got a treatment and who didn't, but you didn't know what any of those differences were before you started out. So then you've got this example of the randomized pre-test, post-test control group design. So unlike those weak designs, you'll notice that we already are starting with an experimental group and a control group, right? Whereas in those weaker designs, 2 of the 3 only had one group. They only had the experimental group. So when we're looking at this post-test design, this is that same experiment here, but you notice what we introduce that's different is this pre-test on the faculty morale. So we get some information about those subjects before the training, and there's potentially some of that information can help us to explain some of the things that we get in the post-test. So this isn't, it's a strong design. It's definitely not foolproof, because what you do with a pre-test is, you're measuring them more than once on what your outcome is going to be. So if we take this example, this idea of morale, Well, when you give them that pre-test, trying to assess a measure of their morale, there's the possibility that you can now influence their their responses on the post test because they know what you're looking at now, right? So sometimes when you introduce a measure as a pre-test, you're giving the subjects an idea of what you're looking at or what you're trying to improve or what you're trying to manipulate. And so this can potentially, oh, sorry about that. This can potentially or have the potential to influence the outcomes on that post test. But the bonus is that you do get more information on how similar the groups are from doing that pretest. And remember, one of the things that you're trying to do in your study is to make your experimental and your control groups as equivalent as possible. And so if you have some of that information before you give the treatment, you have the potential to go back and make two potentially non-equivalent groups. If you figured out that, oh, this experimental group and this control group are really different in significant ways, you have the potential to go back and to use a different method of random assignment like matching to try to make the groups more equivalent, right? So you can then control for a different set of threats that way. So this is a good experimental design, but like all designs, they still have some caveats that come with them. And so this last is this Solomon four-square, four-group design. So you'll see, taking this idea of that same experiment with 100 teachers, you're dividing them rather than two groups of 50, you're putting them into four groups of 25, right? So you're randomly assigning them to those four groups. So you have group 1, group 2, group 3, group 4. You give two of those groups the pretest. You give all of the groups the post test, but then you differ in the treatment. So essentially what you do is one of the groups that got a pretest gets the sensitivity training. One of the groups that did not get a pretest gets the sensitivity training. And then one of the groups that gets a pretest does not get the training. And then the group that did not get the pretest also does not get the sensitivity training. But you do post-test all four of the groups. This is the best control for all of the threats because you're essentially looking at so many different ways to control for it, and then everybody gets to take that post test so you can see how those different factors may have or did not influence the outcome. But if you take a look at this, this can be much harder to do because you really need to have a large sample, right? So you couldn't only have, or you wouldn't want to only have, let's say, 24 teachers and have 6 in each of these groups. That's not a large enough sample. So this does well to control for everything, but it's difficult because you need to have a large sample in order to use a design like this. So I mentioned in that previous slide this idea of random assignment with matching, right? So in terms of random assignment with matching, the researcher wants to, increase the likelihood that the different groups are indeed equivalent. And so the researcher can decide on certain variables that they wish to match their subjects on. So you take the subjects and you match them into pairs, and then you take members of those matched groups and you assign them to either the experimental or the control group. You can do this either mechanically or statistically. So you can use statistics to help you determine what those matches are. But here's an example of using one of the strong or true experimental designs. So a randomized post-test only control group design using matched subjects. So when you took a look at the sample, the researcher may have decided that they thought GPA would be a variable that could potentially be significant to the outcome. So you go ahead, you look at your group of subjects that were randomly selected, and then you put them into pairs based on their GPA. Then, once you have those pairs made, in order to ensure that your experimental group and your control group were as equivalent as possible in regards to GPA, because you thought that GPA might be significant or a variable that you'd like to control for, you take one member of each pair and you put them one in the experimental group and one in the control group, right? And exactly what this diagram shows you. And then this way, if you do the treatment on your experimental group and you do the treatment on your control group, assuming that you didn't have any threat like mortality to one of the groups, you can have a reasonable assurance that GPA should not have influenced the outcomes of this coaching program that you subjected your experimental group to, because you tried to control for GPA by using. So the end of the chapter deals with some quasi-experimental designs. And so quasi-experimental designs are different than true experimental designs. These do not include the use of random assignment, but instead they use some other technique to control for the threats to internal validity. They talked about the matching only design, and it's similar to an experimental design, but there's no random assignment that occurs. But we're going to take a look at the counterbalance design and the time series design, because those are different. So with the counterbalance design, you would use this when you're looking at more two or more variables, right? So what you do is you divide your subjects into the different groups, but each group gets all of the treatments, but just in a different order. Then you compare the average scores on that post-test. So they all take the post-test. One of the things that this does well is that it can help you control for some subject characteristics, but it actually can be threatened by the fact that performance on one of those treatments can then later influence performance on the others, since all of the groups are getting all of the different treatments. So it's not quite the same as a true experimental design, right? So it uses some aspects of experimental design, but rather than having an experimental group and a control group from which the control group does not get the treatment, everybody gets the treatment. You just do it in different orders and then compare the averages of the outcomes at the end. The other is a time series design. So with the time series design, you're doing some kind of pre-test and some kind of post-test, and you're repeating it. So you're doing both of those several times, and what you have one group in this. So you don't have an experimental or a control group. You just have one group, and what you're doing is over time, you're introducing some type of treatment, and you're seeing if the results that they had on the pre-tests then change after they get the post-test. But it's different than just doing one post-test, giving the treatment, It's different than doing one pre-test, giving the treatment, and then giving the post-test, because you do multiple pre-tests to get an average of performance. Then you introduce the treatment at the same time in all of those, or you do all of the pre-tests and then you introduce the treatment, and then you do the same amount of post-tests. So you get to compare the average performance before to the average performance after the treatment. So really you're just measuring something over a period of time to get an idea of the trends or the average performance. You introduce that treatment, and then you measure the changes over a period of time at the end to see if there were any differences in those changes or performance. But considered quasi-experimental too, because it's not a true experimental design in that you're looking at the same group. You don't have the experimental group and the control group. You just have one group. The last one that we're going to look at then is your factorial designs. So with a factorial design, essentially you extend the number of relationships that you can look at in an experimental study. So they're usually modifications of either the post-test only control group or the pre-test post-test control group designs, which allow you to look at additional independent variables, but they also allow the researcher to take a look at the interaction of the independent variable with one or more other variables. And so those are called the moderator variables, if you remember back to like week 2 or week 3 when we talked about variables. So here's a picture of or a graphic of what a factorial design might look like. And essentially a factor is just the major independent variables in the study. So in this case, let's say that you wanted to look at, or you wanted to vary the amount of time students received small group instruction, right? So you might say, okay, I want to look at not just the amount of time that they receive the instruction, but I'd also like to take a look at the setting, right? So your factors in this study would be the two major independent variables, which are the time that they get for the instruction and the setting in which they receive the instruction. Then you have, with these designs, levels. So levels then are just the subdivisions of the factors. So in this case, I keep losing my arrow, I'm sorry. In this case, you can look at the time. You might want to look at, well, what do I get when they get 1 hour of small group instruction versus 4 hours of small group instruction. So this factor of time for instruction has 2 different levels. And additionally, in this study, the second factor of setting also has 2 different levels. So they can receive that instruction in a pull-out setting, or they can receive that small group instruction in the in-class setting. So then what I would do here is I can take a look at how those 2 variables and those 2 factors interact with one another in different ways on different levels. So group 1 can get 1 hour a week in class. Group 2 can get 1 hour a week in the pull-out setting. Group 3 can get 4 hours a week in class, and group 4 can get 4 hours a week in the pull-out setting. So I can look at the effects of different variables and then different levels within those variables. So it's considered quasi-experimental because, again, everybody's getting some kind of treatment, and there's really no true experimental group and control group. And so the book then went to describe, 2 by 2 or 4 by 4, and essentially those numbers just refer to the levels. So if I have, let's say, 2 factors in my study and each have 2 levels in them, just like this one in the graphic, that means that I have a 2 by 2 factorial design. and you use those numbers to determine how many groups you need, right? So 2 by 2, I need 4 groups, like in this one. Let's say that I had two variables that I was, two factors that I was going to look at, but each of those factors, let's say the first factor had 3 levels in it, and then the second factor had 4 levels in it. That would be a 3 by 4 factorial design, and so then I would need 12 different groups in order to take a look at all of the differences there. All right, so the whole idea in all of these designs, or many of the designs that we talked about, was this idea of controlling for those internal validity threats. And so this is just a nice graphic that shows you how the threats can influence your results. So if you take a look here, if you don't control for those threats, but there is a threat present, this is what your results might look like. In your pre-test, you didn't control for it, and this is what your results look like in your post-test. But since you didn't try to control for those threats, you don't necessarily know if your outcome was influenced by them. But you'll see that your results can then be quite skewed. In this graphic, when you try to control for the threat, you'll see that you've got some equivalency here when you begin, right? And so when you take a look here, because you started pretty much at the same spot here, you can have a greater assurance that indeed you had some changes, and you'll see the changes may not be as dramatic as they look from here to here, but because you started off in the same place, you have a reasonable assurance that indeed this change or phenomenon has occurred. If you want to take a look at page 283 for your own reference, or when looking at your for information for your research critiques, you may want to take a look at this page, because they give you some ideas, really good ideas on these specific threats to internal validity, some questions that the researchers can ask themselves when considering their design, and how they can control for these in terms of their methodology. So that's a really good reference on that page for that. So kind of the underlying goal or takeaway from this is that you want to use your designs, or you want to use a design that allows you to control for the things that are the variables that could potentially be a greatest threat to your outcome in your study. And so the designs that you choose are also just like the questions you choose in matching the method. The designs will be dependent on the types of studies you have, and then of course also the resources that you have available.